Welcome friends. Let us see this question. This question says a pair of square parallel conducting plates. This is a parallel conducting plate, right? Let us see. This is a parallel conducting plate of side 0.05 meter. This is the length of 0.05 meter and are 0.01 meter apart. So this is 0.01 meter apart, right? And are connected to a 200 volt supply. So this is the 200 volt supply. This is the positive terminal and this is your negative terminal. An electron is moving horizontally with a speed of this much meter per second. There is an electron which is moving horizontally with this speed, right? It enters the region between the plates, right? And it enters the region between this plate, right? Neglect gravitation and distortion of the electric field around the edge of the plate. So we have to neglect gravitation and any fringing effect, right? There will be no loss of electric field around the edge, right? Determine the magnitude of the electric field in the region between the plates and indicates its direction, right? So we have to find the magnitude and direction of electric field. So we have to find the magnitude and direction of electric field. See, since this is positive terminal, right? This is positive terminal. This plate is connected with the positive terminal of the battery, right? As you can see, and this plate is connected to the negative terminal of the battery or cell. So this will be negative terminal, and we know the direction of electric field is from positive potential to negative potential, right? Positive charge to negative charge, positive potential to negative potential. So we can say the direction of electric field will be downward, right? We can say the direction of electric field will be downward. And what will be its magnitude? So its magnitude will be, we can find, E is equal to, magnitude of E is equal to V upon D, potential difference upon distance between them. So what is the potential difference? Potential difference is basically 200 volt and distance is 0.01 meter. So the value of this will be 2 into 10 raised to power 4 volt per meter. So this is the electric field. Its value is 2 into 10 raised to power 4 volt per meter, right? So this completes our first part, that is the part A, right? Let us see its part B. The part B, determine the magnitude and direction of the acceleration on the electron or of the electron in the region between the plates. So to find the acceleration, we should find the net force, right? We know force is equal to mass into acceleration. So acceleration, we can find acceleration will be force upon mass. We know the mass of electron. We know the mass of electron and force. What will be the force? There is an electric force, right? And what is the electric force? Electric force is basically Q into E divided by M, right? So we know the value of Q, that is a minus 1.6 into 10 raised to power minus 19 coulomb. We know the value of electric field, that is 2 into 10 raised to power 4 volt per meter, and we know the mass of electron, that is a 9.1 into 10 raised to power minus 31 kg, right? After putting all these values, the acceleration will be 3.5 into 10 raised to power 15 meter per second square, right? And it has negative value. What does it mean? It means, see, it means either you think it like a vector quantity. It indicates, the force, since the electric field is in downward direction, but force will be in opposite direction, right? So acceleration will be in this direction. Please note, acceleration will be in positive y direction, right? It's negative with respect to this electric field, right? if we apply with the vector notation, so since electric field is downward, right, so its force will be acting upward and net acceleration will be in y direction. That's why it's negative. We can write acceleration is 3.5 into 10 raised to power 15 meter per second square upward, right? This completes our part B. Let us see part C, right? So determine the magnitude of the vertical displacement of the electron for the time interval during which it moves, right? So when the electron will pass through here, when electron will pass through like this, actually its path will become deviated. It will, right, it will go like this. It will deviate from the horizontal direction. Why? Because there is a force acting in vertically upward direction. There is a force that is acting in vertically upward direction. It's a electrostatic force, right? So what we can do to find the vertical displacement, right, we have to find its vertical displacement. We have to find its vertical displacement. So to find vertical displacement, what we can do, see, since it's since this acceleration is in y direction, acceleration in x direction will be 0 because force in x direction is 0. There is no force in x direction, right? Since there is no force in x direction, so there will be no acceleration in x direction, right? So we can calculate it. Let us see. Since fx is equal to 0, hence ax will be equal to 0. So we can write, we can use the formula. See, we can use x is equal to v into t. If you want to write x is equal to v into t plus half ax into t square, this will be vx. I am applying this formula along the x-axis, right? So since ax is equal to 0, so x, that is the distance traveled in x direction, vx into t. So we can find the t here. What is the x? What is the x? Our x is 0.05 meter divided by vx. What is the vx? Vx is 3 into 10 raised to power 7 meter per second. Please note, this is the horizontal speed or velocity. It will not change, right? It will not change because fx is equal to 0, hence ax is equal to 0. So this speed will not change, right? And this is the horizontal distance, horizontal displacement for which electron has to be traveled, right? So this is the value of time during which electron will pass through this space. So after calculating this value, right, we can find it. Whatever this value we will put in another equation, we have to find the vertical displacement. So again we can apply this formula in vertical direction, right? Let us see. So we can write y is equal to vyt plus half ayt square, right? Initially y direction, y coordinate is 0, right? We are starting from this point, and vy is 0. Initially there is no velocity in y direction, right? So 0 into something 0 plus half ay. We have calculated the value of ay, that is the acceleration in y direction. That was 3.5 into 10 raised to power 15, and we know the value of t. T is 0.05 divided by 3 into 10 raised to power 7 whole square. After solving these all variables, we will get 4.9 into 10 raised to power minus 3 meter. So it will deviate this much. This is the normal path, and actual path will be like this, and it will deviate 4.9 into 10 raised to power minus 3 meters, right? Let us see its part B. On the diagram below, sketch the path of the electron as it moves this. So our value is this. Let's see, this is how much. This is 4.9 divided by 1000. So this is 0.0049, right? This is 0.0049, and right, and this is 0.005, right? Approximately both are the same. So it will, right, it will deviate like this, right? Here it will be deviated, and after this it will go in state, right? So this will be approximately 0.0049 meters, and this is 0.005. So approximately it will touch here, and it will go straight, and this path will be parabolic. Please see, this will be a parabolic path. This will be a parabolic path. This will be a parabolic path, and this will be a straight line. Why? Because here acceleration we have in y direction. Y is equal to uy t plus half of ay t square, right? So there will be a exponential term t square, right? So its path will be parabolic inside the plate, between the plates. After that it will go straight line, right? So it completes our question here. Okay friends, so if you like this video, please subscribe our channel and share it, and please press the bell icon to get the latest notification. Thanks for watching.